Today we're going to look at the law of cosines, which with the law of sines, remember that we had to have a complete ratio, meaning side A and angle A, in order to be able to solve the triangle. We're not always going to have that, and so that doesn't mean we're out of luck. That just means we have to switch then to the law of cosines. The law of cosines is used for side, 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 where you're given 3 sides and no angles, or side, angle, side, 2 sides and the angle in between. The law of cosines comes in many forms, but this is essentially how it works. And I just remember the pattern. So the answer is, remember, lowercase letters are sides, capital letters are angles. So a squared is equal to b squared plus c squared minus 2bc times the cosine of a. Now here's how I remember the pattern. All right, this is given to you on the ACT, and it's on your cheat sheet that I gave you from Unit 8, Chapter 5. But here's how I remember it. The side on the equal sign side, the left-hand side, and the angle have to match. And then the other 2 sides are this one, and then they're also here. It's always a 2, okay? Now, here's the deal. The law of cosines is much more complicated than the law of sines, so we're only going to have to use the law of cosines once. Once we do that, then we'll have a complete ratio and we can use the law of sines. You always want to find the biggest angle first. The point of finding the biggest angle is that this avoids an ambiguous case, which we saw with the law of sines, okay? If you start with a smaller angle, then you're going to have an issue that you have to look for both triangles there. If you find the biggest angle first, that's never going to be an issue. Remember the rule from geometry, the biggest angle is across from the longest side. So that's what we're going to be looking at. Okay, we're going to look at 2 examples. You will need your calculators, and they will need to be in degree mode. So this one is a side angle side triangle. We have 2 sides and the side in between. If we look at our pairs, I have angle A but not side A. I have side C but not angle C. I have side B but not side B. So we do not have a complete ratio here, okay? Now, the only angle that I've been given is angle A. So that's what we need to build our law of cosines formula around. So since angle A is the one I'm going to use, my rule is going to start with a squared. And then similar to the Pythagorean theorem, it's going to be b squared plus c squared. That's not the Pythagorean theorem, but it's a similar pattern. And then it's always minus 2 BC, because those are the ones that are on the same side, and then the angle matches the other side of the equation, so it'll be cosine of A. So we're going to plug in the things that we know. We do not know side A, so A squared is equal to, B is going to be 20 squared plus C is 30 squared minus 2 times 20 times 30 times the cosine of 60 degrees. Okay, here's what's really, really important. And this is the mistake that I often see. The mistake that I often see people do is they combine all of this first. That is wrong because, remember, terms are divided up by subtraction and addition. So we have one term here, and then all of this is connected as one term. So when we work this out, we have essentially 400 plus 900 minus, let's see, we're going to have 40 times 30, so that's going to be 1200 cosine of 60 degrees. We can combine these because they are like terms, but we can't combine it with the 1200 because that's attached to the cosine, all right? In either case, for this particular one, we're just going to type that all straight into our calculator. And we also know that to solve for A, we're going to take the square root. So A is going to be equal to the square root of 1300 minus 1200 cosine of 60 degrees. And you can type all of that in at one time. We don't need plus or minus because A has to be positive since it's a side of a triangle. So square root 1300 minus 1200 cosine 60, close parentheses, enter, is 26.5. Sides to the nearest tenth, angles to the nearest degree. So now we know that side A is 26.5. That's our first answer. Okay. And honestly, guys, you could have done the square root right here and just typed it in just like that. It's all going into your calculator, so it doesn't matter. Now look at what we have. Now I have a complete ratio. I know side A and I know angle A. So I can use that to find the rest. Because we found this, we are not going to have an ambiguous case. Law of cosines does not lead to an ambiguous case because this triangle is side, angle, side. That guarantees congruence, which means there's only one possible triangle that we can build, so you don't have to worry about that. So now we will go back to the law of sines. I will say 26.5 over the sine of 60 degrees is equal to, I'm going to do B, so I'm going to do 20 over the sine of B. So we learned from our previous that this B is going to be equal to the sine inverse of 20 sine 60 divided by 26.5. So put that in, second sine inverse, 20 sine 60, close parentheses, divided by 26.5. We get that angle B, when we round to the nearest degree, is 41 degrees. Again, we don't need to consider a second case because there cannot be a second case here. It's only with our bad word ASS triangles. That's the only time you have to worry about that. This is an SAS triangle, so we're all good. So now, if I know that angle B is 41, we add those together. That's 101. Subtract from 180. We get that angle C has to be 79 degrees. Okay? So that's an example of a side angle side triangle. Let's look at one where we just have three sides. So this is a little bit different because in this case we have to solve for angles instead of sides. The biggest side is B. B is equal to 9, which means the biggest angle is also B. And that's how we want to build our formula. So that means that the left side of our equation has to be B squared. That means I haven't used A and C, so this is going to be A squared plus C squared minus, it's always a 2, then I use the A and C again, and it's going to be cosine of B. Again, these two have to be a matching set, B and B, always. Okay, so let's plug in what we know. We know that B is 9, so 9 squared equals A squared, so that's 6 squared plus C squared, that's 4 squared, minus 2 times 6 times 4, cosine of B, which is unknown, okay? So we have to do a little bit more prep work here because we need to solve for cosine of B. So we get 81 equals, these are like terms, so those we can combine. 6 squared is 36 plus 16, so that's going to be 52. 36 plus 16, yep. And then we get minus 2 times 6 times 4 is going to be 48 cosine B. Again, you cannot do 52 minus 48 because those are not like terms. The 48 is connected to the cosine. So we have to solve this like a normal equation. Subtract 52 from both sides. That gives us 29 equals negative 48 cosine of B. Now divide by negative 48. So we get negative 29 over 48 is equal to cosine of B. So we know what the cosine of B is. Now if I want to know what B is, that's going to be the cosine inverse of negative 29 over 48. Again, there's no ambiguous case with the law of sine. So the answer we get is the answer we get. So put that in, inverse cosine of negative 29 divided by 48. I get 127 degrees. That's our answer for B. 127 degrees. Now, once again, we have a complete ratio. So now we go back to the law of sines to find either angle A or angle C. Then we subtract from 180 to find the third angle. So pause your video and give that a try on your own before I come back with that work in 3 seconds. Alrighty, when you do the law of sines, we have to use the sine inverse to solve for A, and you should get 32 degrees. And then all you have to do for C is subtract 127 and 32 from 180. That tells us there's 21 degrees left. And so those are the two different cases for the law of cosines. And that's all we have to be able to do with that. So we are done, and I will see you next time.